Hello everyone. In today's lecture we are going to learn about recursive functions. Now recursion is an interesting concept in programming language in which a function basically calls itself, or we can say that a function is calling the same function in which it is present. So let's see this through an example. For those of you who do not know about factorial, let me just briefly explain this, that factorial of any number, suppose 5, is equal to 5 into 4 into 3 into 2 into 1. Now I can write this factorial of 5 as 5 into factorial of 4, because I know that factorial of 4 will be 4 into 3 into 2 into 1, which is equivalent to this. Now if I'll generalize this, I can say that factorial of n is equal to n into n minus 1 into n minus 2, and it goes on till 1. Okay, and I can write this as n into factorial of n minus 1 also. So here I can see that factorial is basically a function which computes this complete value n into n minus 1 until 1. So here I am computing this function using that function itself. So inside that function, when I am computing this function, I am using the same function. So basically I am calling a function inside that function. So the function is calling itself, or we can say that. So here factorial of n is equal to n into factorial of n minus 1. So if I observe this, now factorial of n minus 1 will be what? N minus 1 into factorial of n minus 2, and this will be factorial of this will be n minus 2 into factorial of n minus 3. So this will go on. So now there should be a statement through which our program gets to know, okay, I have reached the boundary and I have to stop the recursion now. So to end that recursive loop, we need to give a boundary case. Now in this case, what will be the boundary case? We know that factorial of 1 is equal to 1. So this will serve as a boundary case. So overall, while defining our problem of recursion for solving the factorial of any number, this will be the definition in which this will be our statement in which factorial of n is equal to n into factorial of n minus 1, and we have a boundary case which states that factorial of 1 is equal to 1. Now let's code this particular example and observe how the things go on. So here I am defining a function fact, which stands for factorial basically, and in that I am giving an input parameter, that is num. Now there is a description of my function. In this description it is stated that a function that computes the factorial of a given number. Now as an input I am giving a number whose factorial is computed, and as an output I am returning that factorial value of that input number. So let's see. So I have that input number num, which can be any natural number. So I will first check if that number is 1 or not. So if that number is equal to 1, then I'll simply return 1. Otherwise, if that number is not equal to 1, then I'll return that number multiply by factorial of a number that is 1 less than that number, so num minus 1. So this is it. So here what I am doing, that I am first checking whether that number is 1 or not, because I know that factorial of 1 is 1 only. So this will be my boundary case. And this is my general statement of recursion, in which if the number is greater than 1, any natural number, then it will go into this else condition and will return the value, that is num into factorial of num minus 1. And when this factorial of num minus 1 is reached, then this means that it is again calling that function fact. So it will go again with a different input parameter. Instead of num, this time it will go with num minus 1, and this thing will go on until that num minus 1 value reach 1. So when this value reach, this num becomes 1, then my code will return 1 for that particular function. So we'll again see the working of how this recursion works. Let's just run this. So this is the factorial function we have defined. Now let's test it. So let's give a number 5 only, and then here we are printing that factorial of so I'm using the dot format here, as you already know, num comma fact num. So let's run this. Yeah, so the factorial of 5 is 120. Let's change this number. If I'll do 6, then we know that factorial of 6 is 720. So this is the output that we are getting. Now let's observe how this recursion works. Now in this particular example where we are having num is equal to 5, and we need to compute the value, we need to compute the factorial of that number 5. So these are the steps that are involved in this particular program, in this function that we have just made. So here fact of 5, the step 1 will be that it will call function, that is fact 5, and in that we know that as the 5 is not equal to 1, then it will go into the else condition and will return num into fact of num minus 1, and that is fact of 4. So 5 into fact of 4. So again I am calling here fact of 4. So this fact of 4 will go again into that function, and that will convert into 4 into fact of 3, and then next step will be 3 into fact of 2, and then 2 into factorial of 1. Now at this stage, factorial of 1, the function knows that as the number is 1, so it will go into this if condition and will return value 1. So here finally I got that variable value, that factorial value 1. So as soon as it got, now it goes back to fill all those values that were unknown before, for which we came down to this road. So here as soon as it got fact 1, now it gives the value. Now it will become 2 into 1, 2. Now we got to know that factorial of 2 is equal to 2. So this step 7 will return 2 here, and then we'll multiply 3 into 2, that is 6, then 6 into 4, then 20 into 5, what it is, 6, yeah, so it returns 6 here, and then it returns 24 here, and then it returns finally 120 here. So this is how the working of recursion happens. Now, since we have seen the working of recursive functions, let's discuss about some advantages and disadvantages of it. Now, one of the most famous advantages is that it makes our code looks cleaner. We can solve the same problem using if-else conditions or for-while loops, but using recursion makes our problem very short, or the code length becomes quite short. Now, another advantage is that it breaks the complex task into simple problems which are easy to solve. And recursive functions are best known for generating sequence. Shortly, we'll see an example of Fibonacci sequence, in which we'll be using recursive functions, and that makes the whole problem quite easy and short. Now, one of the famous disadvantage of recursive function is that it requires and it consumes a huge lot of memory and time also. in this case we have seen that while solving the factorial function we used a number that is 5. So here the program is running and the function is calling itself just quite a few number of times, but if that value reaches 1000 or 2000 suppose, then it has to call the function 1000 times, 2000 times, and that consumes huge amount of memory and time. Another disadvantage is that recursive functions are quite hard to debug as compared to for loops or if else normal programming that we do. Now, one more important disadvantage is that while solving a problem with recursion or recursive function, we find that the logic that is there is not that straightforward. In this example, while solving factorial equation, we found that it was easy to observe the recursive function, but when a complex problem comes, then it is really hard to find the boundary case and to get the recursive equation. Now again we'll see another example of recursion in which we'll be solving a Fibonacci sequence. Now what exactly is Fibonacci sequence? For those of you who do not know about Fibonacci sequence, let me explain that it is a sequence which is made by the addition of previous two numbers. So suppose this is a Fibonacci sequence in which this is my 0th number, this is my first number, this is my second number, this is my third number, this is 4th, 5th, 6th and 7th. So in this sequence, these are the basically index, and when I say Fibonacci of 0, then that is 0, and Fibonacci of 1 is equal to 1, and as I can observe through this that Fibonacci of 6 is 8. Now there is a feature of Fibonacci series that Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. We can confirm this here also. This is a Fibonacci sequence that we have already made. Now we can see that Fibonacci of 6 is equal to 8, which is equal to Fibonacci of 5 and plus Fibonacci of 4. So this is equal to Fibonacci of 5 plus Fibonacci of 4. That is equal to Fibonacci of 5 is 5 plus Fibonacci of 4 is 3. 5 plus 3, 8. So here we can observe that any number you take, suppose 3 it is, so it will be the sum of previous two number, 2 plus 1, 3. If we have 5, then 3 plus 2 gives 5. If we have, here we have 13, Fibonacci of 7 is 13. So this will be Fibonacci of 6 plus Fibonacci of 5. So 5 plus 8 gives 13. So this is how a Fibonacci sequence works. So this is basically our recursive equation, which states that Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. So we have found a recursive equation. Now as I have told before that to solve any problem with recursion we need two things. First is recursive equation and the second is boundary case. If you have these two, then you are good to go. So here we have these two as our boundary case. We state that Fibonacci of 0 is equal to 0 and Fibonacci of 1 is equal to 1. Because as this whole Fibonacci series is dependent on previous two numbers, the addition of previous two numbers. So initially we have to give some number to the first two numbers. So here we are having 0 and first, and we are giving the value 0 and 1 to each of them. So this is our initial boundary case through which we can go on and make our sequence. So let's observe this through code. Now what I have done here is that I have defined a function that is Fibo, which will help me make a Fibonacci sequence. Now in that I am passing an input parameter which is num, and that is a natural number. Now what I am doing, that here I am checking whether that num is less than equal to 1 or not. If it is 1 or less than equal to 1, then what I need to do is to just return that num. Why? Because just now I said the boundary case that Fibonacci of 1 is equal to 1 and Fibonacci of 0 is equal to 0. So here if num is 0, then it will give 0, return 0, and if number is 1, then Fibonacci of 1 will be 1. So this thing will cover my boundary case. And for my recursive equation, that I already know that Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. So I am simply writing this definition here, Fibonacci of num minus 1 plus Fibonacci of num minus 2. So this will be my Fibo num. So if the number is greater than 1, then it will go into this else condition and will return this, and this return statement includes the function itself. So here again the function is calling itself. So this is my recursive equation. Now after defining my function, I have to tell how many number of terms I require, because I have given my initial condition, I have given the sequence, the recursive equation. So this can go on. I can get n for, like here I am using 8, so I can take it as 10 also, and we'll see that yeah, so we are having 10 numbers here till 34 it is going. So what I am doing now is that I am printing the Fibonacci sequence here. For that, what I have to do, that I need to give all the numbers, because this num is basically the index, as we already told that this is the 0th Fibonacci number, this is first Fibo, this is second Fibonacci, this is third Fibonacci. So I am giving these number because I need 10 terms, so this will be my ninth. The index will be 9 here because it's starting from 0. So these are the number of terms, and it will take each term, each number. So now it will compute that number that is associated with that index. So print Fibo num. This num will be 0 till 9. So when it is 0, it will go inside it and it will see that the num is less than equal to 1, so it satisfies this, so it will return num, and num was 0, so it will give 0 itself. Then again num will get updated to 1. Now Fibo of 1 will be Fibo of 1, that is again this satisfies the statement. Now it returns the number itself, 1. Now when Fibo of 2 is going here, then Fibo of 2 will be, it will skip this statement, will go inside this, will say that Fibo of 2 will be Fibo of 2 minus 1 plus Fibo of 2 minus 2, that is Fibo of 1 plus Fibo of 0, and Fibo of 1 is 1, Fibo of 0 is 0. So these two will be added and it will give Fibo of 2 as 1. So this will go on, and this loop will call the function. This loop will call this Fibo function each time, and inside that it will compute through recursive equation. So we can see that how this Fibonacci sequence is getting generated. So at the end, I again want to re-emphasize on this this point, that to solve any recursive problem, we need two important things, that is boundary case, and the second is recursive equation. So if you are able to make this, then you will be able to solve the problem. And again, I am emphasizing that to debug this recursive equation, to debug problem involving recursion is quite hard. So we have to be really very careful while making these cases and equations. Thank you.